In mathematics, beauty is a very important ingredient. Um, Beauty consists, as in mathematics, as in architecture and other things, it's a difficult thing to define, but it's something you recognize when you see it. Certainly has to have elegance and simplicity and structure and form and all sorts of things would make up real beauty, and there are many different kinds of beauty. And they have to do with mathematical theorems. And they're important. Beauty is important as a criterion in mathematics because basically mathematics, there's a lot of choice in what you can do in mathematics, like there is in science. And what determines what you regard as important, what not. And I think the aim of the mathematician is to try to encapsulate as much as you possibly can in small packages, much truth, high density of truth per unit word. And the beauty is a criterion. If you've got a beautiful result, really, it means that you've got an awful lot identified in a very small compass, and as opposed to a rather large, waffly, woolly result, which is rather dilute. So I think it's the measure of significance. Beauty is in the absence of experimental science, where your results are tested by experiment, the mathematician has to be tested his significance by some other criterion. And one of the criterions is simplicity and beauty and elegance. That shows him somehow that he's got on the right track, it's truthful and so on. It appeals to you and you like it, but it's more than just you like a pretty picture. Beauty has significance over and above just the immediate attraction of an elegant result. At least there are different levels of beauty, and some beauty is more superficial than others. There's some clever little tricks which don't go very far. Like in pictures, there are some which are superficially attractive, others which are much deeper. And the same is true in mathematical theorems.
There are beautiful results and beautiful proofs. Can you always have both?
Yes, you can have both. And of course, with a beautiful result, the result can be very simple to state. The proof may be very complicated, like with Fermat's theorem. What usually happens is you try to then evolve variations of the proof. The first proof you get to may be not the best way to get there. And if it's a beautiful result, like the top of a mountain, you got there by a very roundabout method, you see if it's a beautiful result, there ought to be a better way. And you go back and you try, and your successors try, and over a long period of time, one actually hopes to find the result which reflects the beauty of the end point by building up beautiful steps in between. You may end up with a whole theory, which is a beautiful road, marvellous scenic views all the way up to the top. So, but of course, that takes time, and the first shot as a beautiful result may be very ugly, and you're very happy to have it at all. But I'm not sure you can have a beautiful proof of an ugly result. That's how inconsistent. You've got a beautiful road ending up with a dump. I don't think that happens very often. You don't go down that road.